Hello, welcome back. We're going to continue our review of limits today, but today what we're going to be looking at are the properties of limits and some special trigs. So let's go ahead and just delve into the properties of limits. They're pretty easy to do. So let's say we have two limits. Now we have limit as x approaches c of f of x is some number L. And the limit as x approaches c of g of x of some number is m. Well, what we want to find out is which algebraic properties can we apply? Well, we can apply pretty much all of them. The first property says that we can add the two limits together. It's L plus M. So just like if you know the value of two functions, you can add those two functions together. The next property we're going to look at is the difference. So if we can add properties and we can subtract limits, then we can subtract the limits. Multiplying, yeah, if we know the value of two limits, we can multiply those two limits together. Likewise, with division, we can divide, provided m can't equal 0. Remember, the one thing we can't do is we can't divide by 0 right there, so be very careful with that one. Our next property is the constant multiple rule. This is a big one for us. What this is saying is that if we're taking a function, multiplying it by a constant, we can factor the constant out. And that's actually kind of really big for us. We're going to use this property quite a bit this year, this constant multiple. Likewise, if we are having a limit to a power, such as right here, we can put the power to the outside. We can just use our limit to that power. Again, provided it's a real number. The last one is the limit of composite functions. We use this one very basically right now, but later on this year we're going to make it much more complicated, especially when it comes to graphing. Okay, so for now, we are going to do easy ones. That's going to disappear there. All right, so let's take a look at how we can apply these here. So, all right, so given we have two limits, f is approaching 2 and g is approaching 3. We want to find the following limits. Now, you're not going to like this because this is going to take a little bit of writing. Again, AP requires a little bit more understanding of the properties. So here, we're taking the limits x approaches a of 5 times g of x. Well, we're going to rewrite this as 5 times the limit as x approaches a. That's that constant multiple rule of g of x. So we can factor the 5 out. That is our there it is, our constant multiple rule. So that's like this little property right here. And now we can go through and go and simplify this. This is 5. G is approaching 3, so we're going to get 15. Now, there is one more property we're going to talk about. That's for example number 2. Notice for number 2 here, we have this limit as x is approaching a of 6 plus f of x over g of x. So we're going to split this up. We can do, on top we have the addition, so I could write this as the limit as x approaches a of 6 plus the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. Now again, in the real world, we just do this much quicker. But let's take a look here. We didn't talk about right here. What is the limit as x approaches a of just 6? Well, remember, what we're saying here is that if f of x is 6, what happens as x approaches some number? So let's take a look at that. Let's put some number down here. Well, here's the function f of x equals 6. It's just a horizontal line. Well, what are we approaching from both sides? On both sides, on the left, whoop, that's definitely not the left. On the right side and our left side, they're both approaching the same number. They're both approaching 6. So the first one is just going to be 6. This is sometimes what we call the constant rule. Not to be confused with the constant multiple rule. But the constant rule says the limit as x approaches a of any number is just that number. All right, plus f of x we know is approaching 2, and g of x is approaching 3, so we just get 8/3 here. Number 3, if we rewrite number 3, we get the limit x approaches a of f of x squared divided by g of x minus 3. So we'll get the limit as x approaches a of f of x squared divided by, let me put this, the limit as x approaches a of g of x minus the limit as x approaches a of 3. So up here, f of x is approaching 2. We get 2 squared over. G of x is approaching 3 minus 3. So notice here we get 4 over 0. Can't divide by 0, so therefore we just say this just does not exist right there. Very easy to do. All right. Graphically, the same way. For number 1, we want here's f of x, here's g of x. The limit as x approaches negative 2 of negative 3 times f of x. So we're going to apply that constant rule. So negative 3 times the limit as x approaches negative 2 of f of x. Negative 3 times f of x is approaching at negative 2. Be very careful. At negative 2, from the right, we're approaching negative 1. And from the left, we're approaching negative 1. So this is just negative 1. So we just get positive 3 there. Take a minute, see if you can split number 2 up. If you need to pause it, we would get 2 times the limit as x approaches 5 of f of x minus the limit as x approaches 5 of g of x. So we get 2. F of x is approaching 2, and g of x is approaching 3, so we just get 1. 4 minus 3, of course, it's 1. Be careful for number 3, we are approaching from the left. We're approaching 2 from the left. So if we look at g of x, as we approach negative 2, be careful, on the left we're approaching 3, and on the right we're approaching 4. So we're only looking at the left-hand side. We know that because of that minus sign from yesterday. So this is going to become the limit as x approaches negative 2 from the left of g of x, and then we're just going to square that whole thing. G of x is on the left. G of x we said is approaching, this is the left side. G of x is approaching 3, so we get 3 squared, which is 9. All right, so I hope you enjoyed the little video right there. Going to part 2, we're going to start taking a look at some special trig functions. I will see you then.